Its workers have been churning out king-size magnets for the steel industry since 1917.
This is one of our Ohio Lodestar magnets. This is not a magnet unless electricity is running through it. The electricity comes in through the external magnet leads, goes into the terminal box, and down into the magnet coil.
Manufacturing an electromagnet this beefy requires several exacting steps. It all starts with a roughly cast carbon steel case. This will house the coil that will carry the magnet's electric current. The first step is to flip the case upside down so a boring mill can hone its interior. This will ensure that the coil will fit inside it precisely.
I have to check my measurements after every cut. That's to make sure that I'm not going over or I'm not undersized. The most important dimensions to hold inside of this case here is the inside diameter and the center core diameter. So the coil can fit in there properly and rest on the bottom and on these shoulders here.
The precisely machined case is also tailored to fit the bottom plate of the magnet, on which the coil will be wound.
This is the bottom of an electro scrap magnet. The bottom will get a layer of insulation, and then around here we'll wrap the aluminum conductor.
Thin strips of aluminum form the coil, tightly wound around a core fixed to the bottom plate. A thin strip of paper called Nomex is layered between each wind. The Nomex electrically insulates the adjacent layers of aluminum from one another to prevent shorting. After the coil assembly is complete, a welder fuses the case and the coil assembly together. Then, workers pour in a proprietary insulating compound that will fill the cavity remaining in the case. The compound will prevent the coil from contacting the inner wall of the case, again eliminating the possibility of electrical shorting. It will also act as a shock absorber as the magnet impacts against the material it lifts. And it will help the magnet keep its cool.
Heat is a magnet's worst enemy. A magnet will lose about 25% of its lifting capability during a day's operation. The role of the compound is important because it transfers heat from the coil to the outside of the magnet case, and then air, which is around the outside of the magnet, cools the magnet to allow the magnet to efficiently operate.
To cure the compound inside the magnet case, workers transfer the assemblage into an oven where it bakes at 325 degrees Fahrenheit for 12 hours. Then, after the magnet passes a series of tests, it's ready for action. As we've seen, lifting magnets make all the difference at facilities like Columbus Auto Shredding. But they aren't the only kinds of magnets the company relies on to extract the recyclable iron and steel. In its processing plant, where derelict cars have an appointment with doom and the ravenous shredder, a variety of magnets await the mangled remains. It'll be their job to separate the iron and steel from the mass of debris. First, conveyors move the shreds beneath these rotating drums. Inside the drums, magnets set at fixed positions direct their attractive force down toward the passing fragments. The magnets draw them to the drum's surface, where they adhere until they're rotated up and out of the magnetic field's range. The shreds then fall to a conveyor. The uncollected shreds move to another magnet, set within the body of this rotating belt, to separate the iron and steel the large drums may have missed.
The magnet is in the center, and what happens is material is processed underneath the magnet, picked up by the magnetic field, and then moved out by this conveyor belt until it gets beyond the field of the magnet where it is dropped off.
On average, the plant's magnets separate 500 tons of iron and steel each day, which the company then sells to recycling dealers. At the junkyard and across the globe, magnets may not always attract a lot of attention, but their contribution is undeniable. One of the most ubiquitous varieties is hanging around in your kitchen. To make it, you have to shake, rattle, and roll. Many cows have magnets placed in their stomachs to attract nails, wire, and other accidentally ingested metals that could harm their digestive tracts. A magnet can safely remain there for the duration of a cow's life. Magnets will return on Modern Marvels. We now return to magnets on Modern Marvels. In our world of technological wonders, magnets are the forgotten stars, performing their vital functions so invisibly we ignore their presence. And of all our unheralded magnets, the one we take most for granted is the enormous one right beneath our feet. The Earth is a giant magnet. An ocean of molten iron at its core generates its magnetic field. The field streams out at the North Magnetic Pole, loops around the planet, and returns through the South Magnetic Pole. This invisible force shields us against the lethal winds of radiation emitted from the sun and distant stars. You can observe this drama in the skies above the Arctic Circle. The cosmic light show called the Aurora Borealis results when the Earth's magnetic field traps solar particles in the atmosphere and deflects them toward the pole. Closer to home, a more mundane variety of magnet plays a slightly less crucial role in our existence, as it clings to the appliance we visit about 11 times each day. Refrigerator magnets have enabled us to turn this nucleus of the American home into an information center and art gallery. Ever wondered where these indispensable little gadgets come from? There's no better place to start looking than FlexMag Industries in Marietta, Ohio.
There's at least a 50-50 chance that the products on your refrigerator were made at this facility.
FlexMag rolls out up to 100,000 pounds of magnets every day. From the strips that secure your shower door to the signs you can stick to the side of your car.
The two main materials that we use in our flexible magnets are synthetic rubber and then also ferrite powder. This material is made from strontium carbonate and iron oxide. This magnetic powder is only very finely magnetic. As you can see, it doesn't really stick to itself very well, so it has to be very fine and airborne before it'll stick to anything metal.
This is where the life of your fridge magnet begins, in what FlexMag calls an intensive mixer. After workers throw in the rubber, bags and all, the ferrite powder showers on top of it.
We use rotors to distribute the material evenly, and then there's a large ram that puts pressure on the mix as it is mixing. Between those two, we get an even distribution, and we readily mix the ferrite throughout the rubber. It takes approximately 5 to 7 minutes to run a batch. Once the material is discharged from the intensive mixer, it's not in a format that we can use, so we dump it into what we call a batch extruder. We maintain the temperature of about 275 degrees through this process.